Fantastic. Now I'm going to share the screen and going to click on assignments, and we're on question 41. Wow, sweet. Ooh, this looks big. First of all, picking up where we left off, remember that if you have two things multiplied together inside of a logarithm, first you split them both apart into their own logarithm. So there's one logarithm for each factor that you have. So that's the first step, plus one logarithm for the other factor, which is x. And then if you had any power that's on the factor, the power goes to the front of the logarithm. So this is the first step, is to do the expanded form of it. The next step is to remember that in the United States, that if we have a logarithm, in fact, actually really not in the whole United States, but just in college algebra in the United States. And the whole logarithm, if you don't have a base, we assume that it's base 10. So that actually is assumed to mean base 10. So how do we find the value of base 10? What power of 10 would you need to get 10 with 9 zeros after it? So the answer is 9, because 10 to the power of 9 would be needed to get 9 zeros. So that actually is equal to 9. So I'm going to change that all to just 9. So the answer is 9 plus log x, like that. Next question. So my goal is to try to get one wrong, but without doing it on purpose, though. Let's see if that will happen. How can you do this one? Well, first of all, you have to express the 3 and the y as being multiplied, not divided. How do I change the 3 and the y to be multiplied, not divided? By putting the y to the power of -1, right? So when you divide by y, that's the same as multiplying by the reciprocal of y, which is y to the -1. And then now that they're multiplied, you're going to take each factor, and so I'm going to draw a line. Oops, not there, but there. You're going to take each factor and do its own logarithm for each factor. So log 3 of 3 plus log 3 of y to the, except to leave off the power though. And then if anything does have a power, it should go in front. So 3 has a power of 1. There should be an invisible 1 in front of this. And this has a power of -1. So you should have a non-invisible -1 that goes to the front of that. So if you put a -1 in front of it, it changes in plus to be a -1. A -1 log 3 of y. So every power that you have on a factor goes to the front of the logarithm, but that's beside that factor. So the answer is log 3 of 3 minus log 3 of y, except that's not the final answer, so don't put that in yet. There's more that you can do. What power of 3 do you need to make a 3? What power of 3 creates a 3? 1. So that becomes 1. Wow, this is romantic, like 2 become 1. Okay, so that becomes a 1. And then we don't really need the 1 in front of that, just the negative. So just 1 minus log 3 of y, like that. So the final answer is just 1 minus log 3 of y, and that's the final answer, right? Any questions about how I could go further than that? I don't think we can go further than that. So there's that. Perfect. Check the answer. Let's see if I get it wrong. Nuts, didn't get it wrong. Okay. I know, but then you wouldn't see me like get frustrated though. Like if I know I'm going to get it wrong, then like it would just be like fake. Okay, so then log base 2. So once again, now I'm going to skip that first step. Technically, you're supposed to say express it as 16 times y to the -1. But can you just remember that it's 16 times y to the -1 in your heads? So I'm going to express it as log base 2 of 16 minus 1 times log base 2 of y. And then we can drop. Thank you very much. That's perfect. Yes. Did you get it?
Sorry, I thought you were gonna call our names today.
No, I left my attendance page in my car accidentally because I was getting my drink and I forgot. My mind just wanders. Like when I go outside, it just thinks about the outside and the fall, the weather, things like that. Okay. Did everybody get signed in on the sign-in page? Fantastic. Okay, good job. You really are an exceptional class. Very amazing. And maybe next time I can give you an update on whether you're beating my online college algebra class or if
For you to move the due date.
but let's just keep on working and see how far we can get though. Maybe we won't even need to. So do you think this is the final answer or do you think there's more to it? There's more to it because guess what? Anything you can mentally do in your brains, or at least you're supposed to be able to mentally do in your brains, you're supposed to do. So what power of 2 creates a 16? 4, you're right. So by the way, doesn't 4 in the volleyball mean you're supposed to like set the ball towards the outside hitter? Perfect. So it's like volleyball. Thanks. Okay, so 4 minus log 2 of y. Boom. Now we're going to expand this one too. We're going to do 1 ln for the e and 1 ln for the 5, except remember the 5 has an invisible power of -1 if you moved it up to the top. So we're going to put a -1 in front of it. By the way, remember, it's not in, it's ln. It looks like in, but it's really ln, like L as in like lemon. So ln and then 5. So ln of e minus 1 ln of 5, but there's something I forgot though. The e has what power on it? E also has power that needs to be moved in front. 6, right? Yep, so 6 has to go in front of it. And then, guess what? ln means log base e. ln really means log base e. What power of e do you need to create an e? 1. So really, ln of e is actually equal to 1. So you have 6 times 1. Okay, I know 6 times 1 is 61. Is that right? No, just kidding. 6 times 1 is actually the 6. Math doesn't make sense to me sometimes, though. So the answer is 6 minus ln 5. And remember, it's ln like lemon, not I. It stands for log. Remember, the L stands for log. Okay. The next one. So this is going to be log base d of the factor of x with the power of 2. When you expand a logarithm, remember the power goes to the front. So the 2 goes to the front. Fantastic. Fantastic. And then this one's going to be log of b. And what happens to the power? When you expand a logarithm, what happens to the power? The power of each factor moves to the outside of the logarithm. So that's perfect. Good job. Well, we're flying by these problems. And then this one is going to be ln of x. And now this doesn't look like a power, but a radical is really actually a certain type of power. A 12th radical is actually a 1/12th power. So we have to move a 1/12th power to the front of that. So to put it in an expanded form, the power of each factor needs to be in front of the logarithm. So it's 1/12th ln x. Fantastic. Then, now there's 2 factors in this one. So log b of z plus log b of y, which stands for like bi. Just kidding. So they know that you're actually kind of like feeling done with math right now, so they wanted to say bye, like bye math on this one. What number has to go in front of the first term though? The power of that factor, which was 3. And now technically there's a 1 in front of that one, but you don't really need to put the 1 because a 1 beside something could be invisible if you want it to be. So there we go. Don't you feel sorry for 1? It's like the invisible, like nobody ever recognizes 1. That's the burden of being number 1. Everybody takes you for granted. Okay, so then number 49, we have to expand it into 2 logarithms, log base 2 of the first factor, which is x, plus log base 2 of the second factor, which is 8. Oops, I forgot the 2. Reminds me of the video about forgetting the blueberries. Did I ever show you the video about forgetting the blueberries? Hopefully. Okay, good. So now, what power actually is technically in front of that second term? because I brought the 8 up to the top. It was really in the bottom, so that's really a power of -1. So you need to put a -1 in front of that term. And what power is actually on top of the x? It's a square root, which is a second root. And a second root represents a power of 1/2, right? Now we're still not done with it yet, though. Because mentally, anything you can imagine in your heads you need to do that's further along in the problem. So what power of 2 makes an 8? 2 to the what power equals 8? 3. So that log 2 of 8 just represents 3, which is the power between the 2 and an 8. So that equals 3. And what's 1 times 3? 13? Just 3, actually. So the answer is 1/2 log 2x minus 3. Boom. Okay, good job. Fantastic. Then, wow, we have a lot, three terms in this one. So it'll be log base b of x plus log base b of y plus log base b of z, except remember the log base b of z has a 3 in it, and it's also in the bottom, which means that it's a reciprocal of the third power. So it's really a power of -3 when you move it up to the top. So that's a -3 in front of that one. And what power does the y have? That has like the invisible 1, which you're number 1, you always get taken for granted, so you don't even see yourself or whatever. Actually, maybe that really means that you should be humble and not think about yourself if you want to be number 1, right? And don't think about how, don't focus on yourself if you want to be number 1. Because Jesus said that if you serve others, you'll be the greatest. So then x has a power of 2, right? So x, that's not really a direct quote from Jesus. Like, just because you served others like one time doesn't necessarily make you the greatest in the universe. But it's the general idea, though. Serving others is more important than being the boss. So 2 goes in front, log base b of x. Is it all done now? I'm always worried. Well, actually, now I'm starting to get worried that I'm going to get one wrong. Okay, well done. By the way, the Bible says, well done, thou good and faithful servant. Enter thou into the joy of thy Lord. When does that happen? Do you know when that happens? When you get to heaven, yep. So assuming you believe in Jesus and you've trusted in Jesus, then when you get to heaven, you're going to get a very good thing said to you. Okay, so then log, what is this? Whoa, this is crazy. Call Me Maybe, actually. Remember that song? Okay, so log of A plus log of B, that's the first step. So log of A, there's one factor of A, one factor of B, but what power does the A have, though? It's inside a fifth root. So what power is a fifth root? At 1/5 power. And now the other one's in a fifth root, but it's in the bottom of it, though. So that's actually a -1/5 power. Boom. So it's 1/5 log A and -1/5 log B. Perfect. Wow, it's incredible. All right, 52. So this one is now that we're condensing them. So do you feel smart enough to condense things? So let's see. So this is going to be a log base 3 of a 108 times 4. What power should the 108 have on it? It has no power in front, which is invisible 1. And what power should the 4 have on it? What should it have on it? An invisible -1, right? But then you should never actually do it that way, though. But that's the technical mathematical way of doing it that like a boring mathematician would do it. We don't want to be a boring mathematician. We want to be smart. 4 to the -1 really means what? The reciprocal of 4. And if you multiply by the reciprocal of 4, that actually means you're multiplying by 1/4. So actually, and if you multiply by 1/4, you're actually just dividing by 4. So in all practical purposes, whenever you see a subtraction, that's really just skip all those complicated steps and just change it to a division. So anytime you have log of A minus log of B, it's just equal to log of A divided by B. They probably don't want me to tell you that shortcut, but that's just a good shortcut to know. The thing is, that's not actually a good shortcut necessarily always to know, because if you had like a number in front of this, like 5 or something like that, then obviously that shortcut would not work, because you should still have to put the power of 5 on it. But it's still a helpful shortcut, though. So when you have log of A minus log of B, that's always log of A divided by B. So what is 108 divided by 4? Big, whoops, that's a big number. 108 divided by 4 Well, 4 into 100 is 25 and 4 into 8 is 2. So what's 25 plus 2? 27. 27 dresses. Isn't there a video called 27 dresses?
Yes.
Okay, cool. Now, what power of 3 makes 27? What power of 3 makes 27? 3 to the 4th or 3 to the 3rd? 3 to the 3rd, I believe. So since you need a power of 3 to make 3 become 27, that's the answer is 3. So the final answer, I believe, is just 3. Isn't that crazy? Wow, this is crazy. Call me maybe. Just kidding. Okay. Next question. 53. We're going to condense this one again. So we have two factors, a log of a y and a log of a z. So it's going to change to y times z. Every factor is multiplied together in one logarithm. And the numbers in front of each logarithm become powers. So there's a invisible 1 on the y. So it's y. Whoops, that's the wrong spot. Whoa, crazy. Visible 1 on the y, and there's an invisible 12. And well, no, there's not an invisible 12. There's a visible 12 in front of the z of the log z. So there's a power of 12 on the z, and there's a power of 1 on the y. I'm going to delete the 1 because we don't need a power of 1 because it's redundant. So there we go. Boom. Any other questions? Should I try that? Maybe actually, let me take out the times sign because you probably don't even need to say times. It can just be yz to the 12th. Check answer. Wow. By the way, the check answer is kind of like the check engine light. In a way, it tells you what's wrong with your math. Okay, so then ln y. So we have a factor of y and a factor of z, so it's going to change into a factor of y times a factor of z. But what goes on to the y? What number goes on to the power of the y? A 1/6, because there's a 1/6 in front of it. What number goes on to the power of the z? An invisible 1. Except you wouldn't want to write it like that because you have to simplify your answer. A 1/6 power really represents what? It really represents taking the 6th radical of something. So we're going to change the y to the 1/6 power, delete that, and change it to be the 6th radical of y. They should write a book called The 6th Radical of Y. Do you think that'd be a scary book or an exciting book? Okay, maybe Tom Clancy could write that book. So ln of the 6th radical of y times z, and I probably don't need the dot, so I'm just going to say that. Make sure that the square root ends after the y, but doesn't include the z. So let's try that. Fantastic. Okay, good job. Then this one, use properties of logarithms. By the way, I had a cousin who didn't say his words right one time, and so I always remembered how cool it was when he said things. He would say like properties, like the paw of something, and he said, instead of saying probably so, he said pobby toe. You know that? Except I think he was just like a little baby, but so if you ever want to say probably so, you can just say pobby toe. That was really cute. So we're gonna have a factor of x and a factor of z. X times a factor of z. What power does the x have? What number is in front of the log of x? 2. What power does the z have? 5. And we don't really need that dot because we're like big kids now. So it's just x squared times z to the 5th. There we go. Perfect. Okay, next question. 56. Okay, so this is going to be 1 ln of x times y. Again, what power does the x have? It has a power of 4. And what power does the y have? -5. Now that's not going to fly. That answer won't work as your final answer. What do you need to simplify to get it to be the final answer? Well, remember y to the -5 means that it's a reciprocal of y to the +5. So you need to flip over the y to the -5, change it to be y to the +5, but in the bottom of the fraction though. So you get ln of x to the 4th over y to the 5th. So notice that in general, whenever you have a negative, well, I shouldn't say whenever, but in most cases, when you have a negative in front of a logarithm, it'll change to be something in the bottom, just because that negative power flips it over and puts it in the bottom. Okay, so there's that. So remember, theoretically, it's still x to the fourth times y to the negative fifth. But in practice, though, you should flip it over and change it to a fraction. So there's that. Okay. Now, this is a new kind of topic. So I think we actually had one of these before a long time ago, but we don't have a log base 12 button on our calculator. So there's no log base 12 button, right? However, though, how do you find the value of log base 12 of 88.5 when obviously your brain isn't programmed to calculate what power of 12 equals 88.5? That's not the number that's in our brains. By the way, did you know that your brains actually have more power than like any supercomputer has, but they don't have the ability to calculate things just by like on demand. Like you can't just tell your brain to like calculate the solution to a math problem like this. Do you know why that's actually a good thing that God made us that way? Because what if you did have the ability to use your brain power to just like compute things like a computer? What do you think would happen? Well, no, then they'd actually make people into slaves. They'd probably just have slaves. Like all these AI warehouses, they'd probably just have slaves in them, and the slaves would just be computing things, like calculated numbers. What?
I do that.
Well, but see, maybe we actually don't even need AI because guess what? If I imagine something in my mind, it's like AI already. Like if I want to imagine 1,000 tornadoes with 12,000 lightning strikes around them, I can just picture that in my mind perfectly.
Picture stuff in that head.
Really? Well, that's actually, well, maybe not. But anyway, though, but actually, I tried that one time. I typed in an AI thing and I said on the image app on the iPhone, and I typed in like 10,000 tornadoes, with lightning strikes all around them, and it could only do like 3 tornadoes, like tops. Isn't that crazy? So it doesn't have AI is still not as powerful as your brain, but your brain can't do things like this though, because otherwise they'd enslave you to make you compute things. So it's actually a safety protection that God made that we can't do things like this on purpose. Okay, so all we do is just take any log that we do have, like 88.5, take the log of the big number divided by the log of the small number, and that's actually the correct answer. So, boom. So just do log of 88.5 divided by log of 12, except that's not the final answer. You have to type it in your calculator. So just go to your super calculator on your phone and just do, and now log on your calculator on your phone, it says log base 10. So I'm going to do clear and then log base 10 of 88.5 parentheses divided by log base 10 of 12 parentheses. So it looks like that. I'm not sure if you can see my screen, but that's just because you have to do log of 88.5 divided by log of 12. And you can also just push ln. It works if you do ln of the big divided by ln of the small. So then I get 1.80409. So this is approximately equals approximately 1.80409. And it rounds it off to 4 decimal places. So which decimal place is the 4th place? That's that one, right? Should I keep the 0 the same or should I round it up to 1? 1, you're right. So I'm going to change that 0 to, so delete the 9 and change the 0 to a 1. That should be the final answer, 1.8041. Wow, cool. Okay, then hopefully there's another one like that. Okay, well, actually, this is a true and false one. Who remembers whether this is true or false? ln e equals 0. Was that true or false? So what power, so remember ln means log base e. What power of e do you need to create an e? What power of e will create an e? A power of 1, right? So ln of e is actually equal to 1 because a power of 1e creates an e. So ln means log base e, and 1e and base e is needed to create the letter e. So the answer is false. It's actually equal to 1, not 0. Genius. Good job. Okay, now we have to determine whether the following equation is true or false. So this is just testing you to see if you have critical thinking based on what you've learned. So if I put the power of 2 in on the right side, okay, this is a little bit tricky. If I expanded the left side, what would I get? I get a log base 5 of 3 by itself. Wouldn't I have a log base 5 of 3 by itself? Plus, I'd have 2 times log base 5 of x. And so I would not have 2 log base 5 of 3. I would only have 1 log base 5 of 3, but I would have 2 log base 5 of x, though. But this says you have 2 log base 5 of both 3 and x. So that's not correct. So the correct answer is that the hold on, let me zoom out. I can't see very much when I'm zooming in so far. The correct answer is, so notice that when you put something in parentheses, it changes 2 things into only 1 factor. So do you notice that in this case, the 3x is in parentheses, so there's just 1 factor of 3x, and the power of 2 moves to the outside. So actually, the given statement is false. The true statement is that log base 5 of 3x with parentheses around it squared would equal 2 in front times log base 5 of 3x. So that's actually the correct answer. Good job. That was a kind of tricky question. I wasn't quite prepared for that. Determine whether the equation is true or false. True or false ones can always be tricky. So is this true or false? There's a lot of stuff going on. This is one where I wish I could write on my screen a little bit more. Can I write? Let me try it. Can I write on my screen or not? Okay, well, actually, I can write on this screen. I just realized that, but that's the computer screen. I can't write on the computer screen. Let's see. Okay, we actually do know one thing, actually, right? What we know, log base 2 will cross out a base of 2, right? So you could cross out the log base 2 and the base 2, and there'd be nothing left. There'd be nothing left except for x times x, right? So if you crossed out the log base 2 and the base 2, you'd have nothing left except for the x times the x. What is x times x? X squared. So actually, this is true, right? Do you agree that this one is true? Yes. So I'd say this one is true. Final check. That always sounds scary. Okay, how about this one? Is this one true? It looks true, but I think there's one falsehood in it, though. So the first step is, I know that I said you could change a subtraction to a division, right? So that is a division, but there's actually one important thing wrong. Before you can actually change a subtraction into a division, you have to change it to a multiplication first, and you have to change it to 1 logarithm first. So log of this minus log of this is actually that there's a negative 1 in front of that. You first have to change it into log of x plus 3 times 4x to the power of negative 1, and it's all inside of 1 logarithm in front. And then the 4x moves to the bottom, but the logarithm is still in front of the whole fraction. But this had the logarithm in the bottom of the fraction and not in front of the whole fraction. So that's actually false. So I wish that there was a way for me to show you what should be true, the true answer though. But the true answer should actually be a 1 logarithm in front. And then inside the 1 logarithm, there should be a fraction with x plus 3 on top and 4x in the bottom. There should not be 2 logarithms both in the bottom and the top. So that's actually false. Okay. How about this one? This one, I think this one is actually true though, because this is the right way of doing it. Here you have a logarithm of one term and a logarithm of another term with a negative 1 in front. So the first step mathematically would be to change it into a multiplication. You have x minus 8 times x squared plus 7 to the power of negative 1. Then you'd put the x squared plus 7 to the power of negative 1 and put it down in the bottom because it becomes a reciprocal. So then you'd have x minus 8 on top over x squared plus 7 to the power of positive 1. And all of that would be inside of 1 logarithm. And that's what it says. So this is correct. Yeah. Right? So that one's true. Good job. Okay, then the 63. Oh, this one's finally a new problem. Okay, we're off of those tricky questions. Those tricky ones are supposed to help you have critical thinking. Do you think that they help you have critical thinking? Or are they just too easy? Because I guess you could actually since they're multiple choice, you could just do them over and over until you finally got it right. So hopefully you won't do that. I mean, I hope you'll do it over and over until you get it right, but I hope that you won't just randomly guess. I hope that you'll think about them first. Okay, so what's the solution to this? Okay, well, there's two ways of doing it. Let's do it the easy way. Yeah, let's do it the easy way. So first, check the equation. 8 to the power of 3x minus 9 equals 512. Is there any way of changing the 512 to be an 8? Is there? By the way, this problem is not such a great problem. It's only an 8 out of 10. Is there a way to change the 512 to be an 8? Well, 8 times 8 is 64. 8 times 8 times 8 is 512. So actually, this 512 can be written as 8 to the third. So that's supposedly the easy way of doing it, but obviously, if you don't know how to do it if you don't know that 8 to the third is 512, the easy way is actually the hard way. So this is the first step, is to change the 512 so it's an 8. And guess what? When you have an 8 on both sides, the only way 8 to some power is equal to 8 to some power is if they're both the same. Because if you have different powers on both sides, then the both sides will not equal each other. So since both sides are equal, they have to have the same power of 8 on both sides. Sorry. No, you're not supposed to write a sentence in the math problem box, but since both sides are equal, they have to have the same power of 8. So that means the power of 8 on the left, which is 3x plus 9, 3x minus 9, has to equal the power of 8 on the right, which is 3. So then you just change it to an easy equation. 3x minus 9 equals 3. Then we're going to add 9 to both sides. So we'll do a plus 9 on both sides. There we go. Have you ever been a plus 1 with somebody? What if you brought 9 friends with you instead of just 1? Then you have a plus 9. Okay, so 3x minus 9 plus 9 equals 3 plus 9, right? And what's negative 9 plus 9? 0. What's 3 plus 9? 12. So 3x equals 12. Then what? Divide by 3. What do you get if you divide by 3? Oops, I ran off the page. You get x equals 4. There we go. Perfect. Sorry, whoops. So the solution set is x equals 4. Boom. Perfect. Good job. Okay. Now, next question, number 64. Try the same method. Is there any way to change the 1/9 into a power of 3? So if you have the problem 3 to the 5 minus x equals 1/9, can you change 9 to a power of 3, first of all? Can 9 be changed to 3? How about by doing 3 to the power of 2? Now, can 1 over 3 to the power of 2 be changed into a non-fraction? Yes, because if I do, what's the reciprocal of 1 over 3 squared? You can change it to be 3 to the power of negative 2. So 3 to the negative 2 is just an abbreviation that means 1 over 3 squared. But now both sides have a base 3. So if you have 3 on each side and they're both equal, then they have to have an equal power. So the power of the left side has to be equal to the power of the right side. 5 minus x has to equal negative 2. That's that. Power of the left has to equal power of the right if the bases are equal on both sides. By the way, I brought this water and I haven't even drunk it because I can't find the straw because it's too dark. Sorry. Oh, there it is. Now, we have to get x by itself. So to get x by itself, I'm going to add an x to both sides. I don't have much room, so that's why I'm not doing it on like separate lines. So add an x to both sides, and then what's left on the left after you add an x to both sides? Just have 5 left. Boom. And then you have negative 2 plus x on the right. What can I add to both sides to get rid of the negative 2? I could add a 2 to both sides. So add a 2 to both sides. And then you get 2 plus 2, negative 2 plus 2 is gone. And you just get 5 plus 2, which is 7. Whoops. Oh, that was just total accident. Wow, we got 67. Okay. I forgot what was the right answer though. 7. 5 plus 2 was actually the answer. So 7 equals x. So the answer should be 7. So the answer should be 7, right? 7, which is like a lucky number. Cool. Okay. Now, wait a second though. So that works great until you run into a problem like this. What's the problem with this problem? What's the problem with this problem? Oops, I pushed the wrong button. Yeah, there is a problem. So how do you make it go full screen? There we go, F11. There we go. That's more space now. The problem is that the way we've been doing it is the easy way. I showed you how to do it by changing both sides to the same base. But 28 cannot be changed, at least not humanly. 28 cannot be humanly changed into base 3 because it has an infinite number of decimal places if you did. So 28 is not a power of 3, that's why. So I'm stuck, right? How do you solve the problem if there's no way to change the one side into the same base as the other side? Because like 3 does not go into 28. Well, here's how. This is why this is in the whole chapter, which is about logarithms. Because watch this. If I multiply both sides by a logarithm of base 3, like this, so do logarithm of 3 of the left and logarithm of 3 of the right. Now, by the way, the other math teachers would probably just fire me if they heard that I said multiply both sides by log 3, because you're not really multiplying, you're just applying to it. So you're applying log base 3 to the left and you're applying log base 3 to the right. You're not actually multiplying by it because that's not a number. But if I apply log base 3 to both sides, now remember log base 3 crosses out base 3. So the only thing left on the left is x. So is it okay if I just erase that and change it to an x? So that's the answer. Now this is the exact answer, but it's not in simplified form because they want us to have it in terms of natural logarithms. So remember that we learned a few minutes ago that if you have log base, a different base like 3 or 12 or 13 or whatever, you can change that into a natural logarithm by typing ln of the big number divided by ln of the small number. So log base 3 of 28 is equal to log of the big number 28 divided by log of the small number 3. And then that's the answer. So the answer is ln of 28 divided by ln of 3. Cool. Nicely done. And now the solution set in decimals is, okay, let me use my phone. It's ln, clear. It's ln of 28. Make sure you close the parentheses after the 28. Divided by ln of 3, and then close the parentheses, equals 3. Wow, what's the thing get in the way? 3.034, no, 2 decimal places. So it's just 3.03. That's all. 3.03, nice work. Wow. Okay, 66. Okay, so this one says, what's the solution in terms of natural logarithms? Okay, we're going to do this one the same way. So we're going to apply a log base 5 to the left side, and then 5e to the power of 8x. Oh, no, that's actually, well, oh, that's stupid. No, don't do a log base 5 to both sides. First step is, did you notice 5 goes into both sides? See, the left side, 5e to the 8x, and the right side, 685, both of them can be divided by 5 because 5 actually goes into both of them. So if you divide the whole equation by 5, this 5 will cancel, boom, and 685 divided by 5 is what? I think it's 137. I could be wrong. Can somebody check me on that? Oh, yeah, but at this point in time, my pride is kicking in, and now I don't want to be wrong anymore. But yeah, you're right. Actually, I did say that. 685. Pride goes before a fall, though. Remember, so now that I'm getting prideful, I'm probably going to be wrong pretty soon. Yeah, it's 137, I think. 685 over 5. So now the solution equation is e to the 8x equals 137. Okay, now I'm ready, and instead of doing log base 5 this time, I'm going to do ln this time. Because why? Because ln actually means log base e. So apply an ln to the left, boom, and apply an ln to the right, boom. Now ln is really means log base e, and log base e crosses out base e. So the ln and the e cross each other out, and what's left on the left? The only thing left on the left is 8x. So you get 8x by itself equals ln 137. Now divide the 8 on the left, divide by 8, boom. Oops, not 80, but 8. Divide by 8 on the right. So then you'll get x by itself, boom. X by itself will equal ln of 137 over 8. By the way, did you know that ln 137 has been gaining too much weight? Guess what? Because ln 137 over 8. So the answer is ln 137 over 8. Hopefully. Do you think that's right? Okay, it is right. And then you have to do a decimal form of it. That's boring, but I guess I can do it. In fact, I hate decimal forms because that's just busy work. ln 137. Clear, wait, forgot to clear first. ln 137 divided by 8 is equal to point. It's terrible. How am I supposed to do on this? Okay, there we go. Okay, it's 0.61. So 0.61. Yeah, there we go. Good job. Wow, this is tough. Okay, what's the solution in terms of natural logarithms? Okay, good job, everybody. Let's actually have an idea. Let's do this on desmos.com. They're great. Instead of mathlab.com. They're great. Okay, first I need to push F11 to minimize the, oops, push the wrong button. Okay, let's open a new window. Let's go to desmos.com. They're great. Then let's put that window on the right and put this window on the left. And we have 1200 divided by, okay, what are we going to do first? We're going to divide by 1200, right? If I divide by 1200, I just get e to the 0.055x. And now if I did 6,000 divided by 12,000, what's that? Let's do that on another line. What is 6,000 divided by 1200? It'd be 5. Sweet. So if I did that on the right, I'd have e to the 0.0555x equals 5. So does everybody see how I got that equation? By dividing by 1200. Now I'm going to apply an ln to both sides of it. So ln of that and ln of the right. Whoops, I forgot to push the arrow key to get down out of the power. There we go. ln of the right. Boom. Does everybody see how I got that? Apply an ln to both sides. Now cross the ln and the e out. If I cross the ln and the e out, you just get 0.055x by itself equals ln of 5. Then my next step is to divide by 0.55. So x equals ln of 5 divided by 0.055. That's the exact answer. So x equals, close that, zoom out a little bit. Whoops, that's a little too much. Whoops, that's a little too much. There we go. Solution set is ln of 5 over 0.055. Boom. And then the decimal solution is 29.26. If you round it off to 2 decimal places, it's 29.26. Wow. Crazy. This is sad. Okay, so let's go to the next one because we only have 4 more minutes. Tragic. Okay, so this one is e to the power of x minus 3 equals 418, right? Boom. Now what we're going to do to get rid of the e is what? Apply what to both sides? What function can cross out an e? L what? ln. By the way, ln means log natural because in French, they say adjectives after the nouns. So it means natural log, but in French though, so like log natural. So ln of e, what happens to ln of e? To a base of e. ln and then a base of e, what happens to it? They eliminate each other. So the answer is x minus 3 by itself equals ln of 418. Boom. And then how do I get x by itself? By moving the -3 to the other side. So you get ln 418 plus, whoops, not plus 4, plus 3. There we go. So the solution set in exact terms is, oh, I made a huge mistake. Does anybody notice my huge mistake? It's a 3, not an E. That should be a 3. This should be a log base 3. I love it. I'm glad that we're having so much fun. Log base 3 of 3 to the power of x base minus 3 equals log base 3 of 418. And now the same, oops, oh no. I deleted it accidentally. I'm trying to click on the parentheses to add it. I guess you can't, because there, wait, it was there. I thought the parentheses was missing this whole time. Okay, so now the log base 3 cancels out the 3, so you still get x minus 3, but you don't get ln of 418, you get log base 3 of 418, right? So I fixed my mistake. Now I need to change this to be log base 3 of 418 plus 3. But it says in the computer, it says I need to have natural logarithms, not log base 3. So how do I change log base 3 of 418 to be a natural logarithm? Well, all you do is to change the log base 3 of a number is to do natural logarithm of the big number over natural logarithm of the small number, like that. So that's the solution set in terms of natural logarithms would be ln 418 over ln 3, and then go over plus 3. Boom. Hopefully. Wow, nice work. Okay, and then as a decimal, round it off, it'd be 8.49, like that. Okay, so we didn't quite make it all the way to 75. Let me look ahead at those ones real quick. Let me just see if there's anything urgent. But thankfully, I did do all the ones on the test already. So here's what I'll do. I'll extend the homework until Sunday, I guess. But the test will still be due on Sunday, though. So you're welcome. So make sure you get the homework and the test both done by Sunday. And I'm sorry I didn't show you how to do the last few homework questions. But it was fun while it lasted, though. Good job. So I guess that was my mistake. I didn't get through them all. Sorry about that. Okay. By the way, keep up the good work. And by the way, my advising meetings are mostly over. So feel free to come back and go to my office more if you want to.